Hey guys, it's Matt Monday again, and today we're gonna show you again how to beat the heat using two neat little tricks. Stay tuned.
So here we are again in NetFab, and this is a part we received from a customer, and he wanted to print this on his machine. And well, we were together looking for an ideal orientation, and if you look at the orientation map in NetFab, there are several orientations that are suggested, but the customer wanted to have minimal support, so that was his goal. And all these minimal support options place the part in this sort of way, plus or minus. And in the last video I showed you that well, if you use the build time histogram, you want to avoid having long layer times on the top and small ones on the bottom. So in this case, you don't really have a choice because the part requires to be printed this way because the customer wants to have as little support as possible. So there are two things you can do to still beat the heat on this part. So the first one is, well, we only have a very minimal support area down here, and we really need to get all the heat out of the part through mostly this area down here. And what we can do is we can jump into the supports, and I know that these surfaces here should not have very massive support. They should come off easy because it's a functional surface later on. But these surfaces here, doesn't really matter how they look, and it doesn't really matter how much support there is on there. So what we can do is we can simply add more rigid support here to get more of the energy out through this area. So now it added some more rigid beams here, and we can do this for these other surfaces as well, and we can even increase how many beams it's going to create on the surface. So that way you have a lot of heat that can flow out through the part. Okay, so we added a more rigid type of support down here to get rid of all the heat in the part, but sometimes this will not be enough. And luckily, this part is an application where the customer actually wants multiple parts. So what you can always do is try to increase your layer time in general. So it will take longer for the laser to jump back to the same spot in the powder bed. So what we can simply do is we copy the part and make more instances of it. So that way we now have 4 times the part, and I think the customer actually wanted 4 of these parts. So that way you get a longer build time in general, and once this part is printed, the other parts can cool down a bit. And what you can also do, if you only want to print one part, you can simply add a second part where you only assign parameters that are actually with 0 laser emission. So that way each layer time will take quite longer, and you're not adding power to the process, but you will get a better heat dissipation in your part. Okay, so here I added an inverse cone, and I assigned a different parameter. I called this one demo, and this one has actually 0 laser power emission. So the higher my part gets, the longer wait time I'm creating due to this, and I can have one part that's cooled down better. Of course, this will slow down your build job, but it will increase your success rate because it's less likely that your part will overheat. Alright, that's it for today. If you have, again, any questions or recommendations what we should do next, leave them in the comments down below, and I will see and hear you next week. Bye bye!